In the stillness of Nevada's desert, something colossal is rising. Beneath the scorching sun and endless sky, steel, silicon, and ambition are reshaping the land. It's not just a rail line or a mine, it's an engineered rebirth. And by 2025, the most overlooked state in the West is becoming one of the most important. Gigafactory growth, Tesla's expansion in Sparks. 20 miles east of Reno Sparks, in the arid plains of northern Nevada, a titanic megaproject is transforming the landscape of manufacturing. This is Tesla's Gigafactory, a sprawling facility first conceived in 2014, now entering its next chapter with a $3.6 billion expansion, adding 4 million square feet of production space. At the core of this expansion lies the engineering challenge, to construct two new disciplines in one complex: a 100 gigawatt-hour, 4,680 cell battery plant, and Tesla's first high-volume semi-truck factory. The civil engineering of this expansion begins with massive groundwork. Steel frame superstructures now rise where once empty grading lay. According to local coverage in early 2025, exterior walls of the semi-facility were already completed, with the structural steel mainframe taking shape and getting ready to receive production line modules. Subsurface foundations have been engineered to carry enormous dynamic loads. Rolling gigapress installations, heavy automated conveyors, and overhead cranes for battery pack assembly. Inside, the mechanical engineering layout is equally formidable. The 4,680 cell factory requires precision climate control, Class 100 clean rooms, localized temperature and humidity conditioning, air filtration using HEPA modules, and dust control airlocks for electrode handling. High-pressure natural gas lines feed industrial HVAC systems for dry room dehumidification and process heating. These lines have been installed as part of the infrastructure planning from the outset. Electrical engineering is critical. The peak power demand for a 100 gigawatt hours per year lithium-ion cell plant is immense. Tesla's engineers are implementing high-voltage electrical distribution systems, medium-voltage switchgear, transformers, and redundant backup systems to supply continuous power to electrode coating lines, cell assembly robots, curing ovens, and test stations. On the semi-plant side, gigawatt-scale charging infrastructure must support factory QA and integration testing with substation transformers and industrial DC fast-charging rigs. Plumbing and utility engineering play a vital supporting role. The cell plant requires purified water systems, deionized water for coating, alkaline cleaning, and electrolyte formulation. Process piping distributes high-purity solvents and lithium-based electrolytes. Fire suppression sprinklers are installed throughout using hydraulic calculations to meet NFPA standards. Cooling water systems circulate through heat exchangers to maintain roller presses and battery pack assembly machines within narrow thermal tolerances. Automation and robotics define the internal choreography. Tesla's existing operations in Nevada already utilize high degrees of automation: bandolier wand loading of cylindrical cells, robots to transfer cells to assembly fixtures, and automated drive unit assembly with over 90% line automation. Now, the expansion intensifies that. New robotic gantries, machine vision inspection stations, and PLC-controlled conveyors are being integrated into both the battery and truck assembly lines. Project leadership for the expansion underscores the complexity. In mid-2023, Tesla hired Michael Hildebrand, a veteran capital projects executive, as head of Gigafactory Nevada, expansion engineering and construction, bringing decades of experience in multi-billion-dollar manufacturing programs. More recently, engineering leadership under Robert Jackson is steering growth engineering with a focus on innovative manufacturing solutions, sustainability, and efficiency. The supply chain overlay is also a feat of industrial logistics. Raw materials, lithium hydroxide, graphite, cathode powders will arrive by rail into the Tahoe-Reno Industrial Center, offloaded into dedicated receiving areas. Inside, automated material handling systems route incoming materials into electrode prep lines and electrolyte mix rooms. Completion of the